Now that I've shown you what the unit circle is, I am now going to show you how to use it, why it is so helpful. These problems that we're about to do are extremely straightforward. They're easy. But by the time we get through the rest of the unit, these are some of the problems that students miss on the test. And there's no reason for it. So don't overcomplicate these problems. These points on the circle, these are referred to as the special points. We can remember their values pretty easily. So all the labeled ones. Anything else on the circle in between, those are referred to as non-special points. We're going to look at those separately. Let's start with the special points, the easy ones. Before we do some examples, I just need to refresh your memory on the very important conclusions we made yesterday. We have established that for each point on the unit circle, x comma y, the first two, if you haven't already absorbed this information, do that ASAP. X is equal to which trig function? Jack? Other one. Cosine, yep. X is cosine, so y is, yes, y is sine. A lot of students get them mixed the first few times because we always say sine, cosine, tangent. Unfortunately, it's backwards with a point. Yes?
And is x over y tangent?
Yes. Or other way, sorry.
Y over x.
Y over x, yes, you're correct. And the final rule, tangent of theta is equal to sine over cosine, which is also just y over x. You can memorize that however you please. I always remembered y over x. Now I'm at the point where I remember sine over cosine, but that takes practice. We're going to use these rules to answer the questions below. And these are quick problems, so we're just going to do several of them. I'm going to give you some very important directions. You will see them again on your homework, on your quizzes, and on your test. So make sure you remember these directions when you see them. Find the exact, and it will be underlined like that as well, exact functional value for each problem below. When we say exact, we want the real, raw, accurate answer. If you round or estimate, that's not exact. That's an estimated answer. So really what this is implying, no decimals. What that means is you will use the unit circle. These next couple problems, I am going to over-explain what is going on here. More often than not, you guys are just going to write down the answer, and that's fine. But I'm going above and beyond just to make sure you understand what's going on here. First example, sine of 30 degrees equals, if you already know the answer, don't give it to me. What we do, and this is why we have the unit circle. We go find 30 degrees on the unit circle. It's in the first quadrant. And I'm going to write down this point. At 30 degrees, the point is square root of 3 over 2, 1/2. And we just discussed the x value, that is cosine. The y value, that is sine. So, sine is 1/2. That's what that means. Sine of 30 degrees is equal to 1/2. Look at the right point, identify the number, write it down. That's all you have to do. Let's do another. Cosine of 315 degrees. Again, you go to the unit circle and you find the point. 315 degrees, that's in the fourth quadrant. Point, rad 2 over 2, negative rad 2 over 2. We want cosine, so we care about the x value. Let me wipe that out. Oh, that's a miswrite. Cosine of 315 degrees is square root 2 over 2. That's all you do for sine and cosine. Very straightforward. So you have to use the circle to get these answers. In fairness, you could have done number 1 with the calculator, and then knowing that 0.5 is 1/2 would have worked in your favor. But your calculator will never ever turn this into square root 2 over 2. If you type this into your calculator, it will spit out the decimal. If you tell it to turn it into a fraction, it will not turn it into this fraction. This is an irrational number. Calculators don't work with those. So that's why we have to use the unit circle. If you put a decimal here, clearly you just used your calculator, it's wrong. I need the exact answer. So that's what I'm talking about here. Let's do a tangent. Tangent of 120 degrees first go to 120 degrees on the unit circle. 120 degrees, that's in quadrant 2. The point here is negative 1/2, square root 3 over 2. I'm going to write that down. Gentle reminder, x is cosine, y is sine. And we need to use that third rule that we discussed. Tangent is equal to sine over cosine, which is also y over x, however way you want to remember it. Let's use that. Tangent of 120 is equal to sine over cosine. If we're going to get technical, it's sine of 120 over cosine of 120. That's just me being extra specific. Sine of 120, that's the y value. That's square root 3 over 2. Cosine, negative half. I glossed over this fraction trick that I showed you yesterday. I'm going to make a note about it in these notes if you want to write this down in a moment. But reminder, when you divide two fractions, if the denominators are equal, then they cancel out very nicely. Reminder, every fraction on the unit circle and the points has a denominator of 2. So this is going to happen every single time. That's very convenient. This creates a new fraction, square root of 3 over negative 1, which is just negative square root of 3. Yes?
If your calculators, how do you turn it into a fraction?
You can't.
You can't.
You can't. Not with irrationals. Nope, it won't do it. I'm going to make a note about that algebra trick if you want to write it down. Fraction over fraction. Denominators cancel if they are equal. We're going to use that trick a lot in this unit, and then we're going to do quite a bit of fraction work next semester. That's where I'm a little nervous about students misusing that rule, because that does happen a lot, but this unit, it's not bad. Let's do one more problem. I'm going to make this very simple. Believe it or not, this works in radians as well. Sine of 5 pi over 4. You're doing the exact same thing, except your question's just being asked in radians. So again, you find 5 pi over 4 on the unit circle. That's quadrant 3. And then you write the point down. The point at 5 pi over 4 is negative square root 2 over 2. Negative square root 2 over 2. And we want the sine value. Luckily for us, sine and cosine are equal here, so if you happen to look at the wrong one, you'll still get the right answer. That does not happen often. So sine of 5 pi over 4 is negative rad 2 over 2. That's how you handle specials on the unit circle. Now let's talk about non-specials, all of those extra points in between. Luckily for you, non-specials aren't on there, so the only way to get those answers is using the calculator. So if you have a non-special problem, here's what your directions will look like. Find the functional value of each problem below. Round answers to 3 decimal places. This part is just an FYI, just to put this on your radar. These angles are in DMS. I threw this at you a few weeks ago. What does DMS stand for? No one remembers? D is for degrees. What's the M for? No one? You all filled out vocab on it. Degrees, minutes, seconds. DMS, degrees, minutes, seconds notation. I wanted to show you all that ahead of time so that there wouldn't have to be a big conversation about it now. We just talked about it earlier. So DMS is going to be the preferred notation, the preferred unit of measure in your answers for the next test. So let's do a couple of these. Cosine of 378 degrees, 20 minutes. We're going to do this in the calculator. You have to know where the buttons are. First things first, this is going to be a major growing pain of this unit. If you look at the top of your calculator, if you have mine, it will clearly say at the top radians. This is in degrees. So if you put this into your calculator in radians mode, it's going to give you a radian answer. You want a degrees answer. Unfortunately, every single time we reset our calculators for a test or a quiz, this is the default, not degrees. So every time you reset, you have to manually change this back to degrees. So this is a setting. All of your settings are under mode. Go to mode. And for me, it's the fourth one down. There's radians and degrees. The highlighted, or the darkened one is what it is. So I'm over degrees now. I'm going to hit enter to flip it. And you know when you've done it if the top says degrees. And then quit to get out of it. Make sure your calculator is in degrees if you do the whole thing in radians in your calculator. Wrong answers. Let's type this in. Hopefully you've already found the trig buttons. They are about the middle of the calculator. Sine, cosine, tangent. We need cosine. Cosine, 378. For your DMS problems, there's one menu you need to be very familiar with. That's the angle menu. It's above the word apps. So you're going to hit second apps to get there. And you're going to see this menu here. We're not going to use all of these. The top button is the degree symbol. I'm going to need that. Second is the minute symbol. And then option 4, this is converting to DMS. We're going to use that later. So hit the degree symbol. And then type in 20 because it's 20 minutes. And go back into that angle list. Grab option 2 to get the minute symbol. And there you have it, fully typed out. Hit enter. Round that decimal to 3 places. 0.949.
What do you do for the second? If it was
So that's a good question. In here, we're actually never going to use seconds. We're always going to round seconds to the minute. I'll show you how to do that later. But I believe there is a button on the calculator for the seconds, but you won't have to type that in. Let's do one more. Sine of 179 degrees, 20 minutes. What's very convenient is once you have this typed in one good time, you can just copy and paste and change it to what you need. So we have sine of 179 Minutes are still 20 minutes for this problem, so I don't have to change that. And then we just round that decimal to 3 places. 0.012. Yeah, okay, so let me explain that. I had a feeling I was going to lose someone. So copy and paste, you can do this at any point. You just go up through your history, and I can go back through everything I've done, which I reset my calculator, so this is it. But any highlighted line, I'll hit enter on it, and it pastes it. And you didn't know that? It's so helpful.
Yeah, it looks very helpful.
It's very helpful. I'm sorry that I'd never shown you before. It's a wonderful hack. So yeah, you can always copy and paste things. I do that all the time. It saves you a lot of time and energy. So finding them with the calculator, pretty straightforward. You just have to know where the buttons are. And that is all we have time for today. We'll do some higher level examples later.